Okay, Unit 4, Skill 5A. How do we solve and check radical equations? This is the first day of 2 parts, and it's the easier day, so it shouldn't be too bad. Alright, get that copied down. So consider the two functions, f of x equals the square root of x minus 5, and g of x equals 2. Alright, so we are going to graph those points and solve this problem. So I'll do g of x in red. So it's always 2. G of x is always 2, which means y is always 2, which is the y equals line. That wasn't bad. Alright, so there is g of x. And then we have to graph f of x. Well, we can make a quick table for it. Probably don't want to use the values like 1, 2, 3, or even negative values, and the reason being for that, I have square root of x minus 5. When I plug in 1, 2, or 3 minus 5, I'm going to get a negative number. And square root of a negative number is imaginary, and I don't know about you, but when I look at the graph, I don't see any imaginary numbers on here, right? Negatives, positives, so on and so forth. So the first number that we're going to want to use is going to be 5. Because 5 minus 5, when I plug it in over here, is 0, and the square root of 0 is still 0. Alright, now I can plug in 6. 6 minus 5 is 1. The square root of 1, of course, is 1. Plug in 7. 7 minus 5 is 2, and the square root of 2, I don't know. Well, it's 1.41, blah, blah, blah. But anyways, it's the square root of 2, and we're going to leave it like that. 8 is the square root of 3, because 8 minus 5 is 3, and then we square root it. When I get 9, again, I plug 9 in here. 9 minus 5 is 4. Square root of 4 is 2. And the last one is 10. 10 minus 5, square root of 5 is what that becomes. Okay? So, we got to plot some points. So, without using your calculator, plot the points for g of x. I kind of already did that. And now I need to graph f of x. So, we'll start 5, 0, count over 1, 2, 3, 4, 5. You should also know that it starts at 5, 0 simply because, hey, look at that, it's shifted to the right 5. So we start here, shift right 5. Okay, 6, 1 is another point on the line, so over 6, up 1. And 7 square root of 2 is really not going to be that easy to graph since I have a bunch of other good points. I'm good to go. So 7, 8, 9, up 2, and there we have it. Okay, we'll label this bad boy f of x, label the point of intersection, which is 9, 2. Okay, and we're pretty good to go. Now, the next question says state solutions, because you do want to know that you solved an equation. It's saying where are they equal? And just like pretty much every other problem, all right, whether it's increasing or decreasing or whatever we're working with, we care about the values of x. So where is f of x equal to g of x? Well, they're going to be equal at 9. And there's our answer. So that problem does not have to be solved graphically, although it's not a bad way to solve it. You can also solve that same problem algebraically. So if you take a look right down here, I have the exact same question. All right, I have a square root of x minus 5, and I have a 2. So if I were to decide that I wanted to set f of x equal to g of x, this was square root x minus 5. Here it is. G of x was 2. So I could set them equal to each other and just solve it algebraically. Turns out that in this case, that's a heck of a lot faster. So the idea here, all right, is step 1, set the equations equal to each other. All right, that's what we just did. All right, step 2, square both sides to eliminate the radical. Okay. We do need to make sure that the radical is alone first, but that's the idea. So square both sides to eliminate the radical. Solve the new equation. Sometimes it will be linear, you just get x alone. If it's quadratic, you're going to get it set equal to 0, which I know we've talked about a number of times. Check the solution and eliminate extraneous roots, and that is something that we will need to do. We'll need to plug it into the table or the graph, or just do a basic algebraic check. So here we go, first problem. The radical is all by itself, so the next step is square both sides. What I do to one side, I've got to do to the other. The square and the square root cancel with each other, so I'm left with x minus 5 equals 4. and then when I add 5 to both sides, I get 9. And it is that simple, which was much faster than the solving it graphically. Alright, so the algebraic check is where you just take and plug in the 9 in for, ooh, that's going to be tough to write this small. So square root of x minus 5 equals 2. We're going to take and put the 9 in place of the x. So we get 9 minus 5. Alright, so the square root of 9, and that should be a minus sign, it's just not a very good one. Square root of 9 minus 5 is the square root of 4. And obviously that is 2. That is a check. The graphic check is right above. You can very clearly see when you look up above. Come on, let's go. Right here, obviously that it crossed right at x equals 9. So there's the answer. And that's the idea here. So let's move on to the next page. Alright, next problem. Solve for x. Let's make this a little bit bigger. So 2x minus 1 plus 5 equals 2. Alright, so the first step is isolate the radical. So I have to get rid of that 5. So the square root of 2x minus 1 is going to equal negative 3. Now the radical is alone. Now that it is alone, I can square both sides, which gives me 2x minus 1 equaling 9. I can now add the 1 over and get 10 dividing by 2 hopefully will give you 5. That's that. So the algebraic check, let's try it. So square root, come on, keep up, of 2 times something minus 1 plus 5 equals 2. That is a horrible 5, I'm sorry. Alright, and that number that we're plugging in there is 5. So what is 2 times 5? That's 10. 10 minus 1 inside here is 9. So it becomes square root of 9. Plus 5 equals 2. And that's right, 3 plus 5 equals 2. Or maybe it doesn't. So what did we do wrong? I don't think we did anything wrong. I'm a math teacher. I shouldn't have done anything wrong, right? Well, people make mistakes. Let's just go back through and double check. Okay? Looks like I squared everything. I added the 1 over, divided by 2. Everything looks perfect. Okay? We didn't do anything wrong. In fact, I knew at this stage of the game, well, right here, but I knew right when we got to this line for sure that it was never, ever, ever going to work. And the reason being, the square root of a number, what does it always have to be? Square root of a number is positive. All right? A positive number times a positive number has to be when you square it. So a negative is not going to work. You can never square a number and get a negative. So as soon as I saw that right there, that negative 3 and square root had to equal it, didn't matter what was under here, it wasn't going to equal a negative. Or you can look at the line above and say, well, this square root has to be a negative to make this become 2, because the only number that works is negative 3 plus 5 to make 2. So it's not going to work. All right, it's the one time you get to point, laugh, and call this bad boy a reject. Yep, you get to do that. So that means the answer is there is no answer. So we go like this. Empty brackets, meaning there's no answer. The graphic check, kind of important to do. We're going to pretend that we have a calculator here, or you can just kind of think about it in your head. So, so the first one on this first side that we're going to be graphing right here, all right, is going to be y equals 2. Okay, so there's our line y equals 2. Come on. And then we need to graph the other one, square root of 2x minus 1 plus 5. So the whole thing is shifted up 5. Okay, so, and then to the right and stretched. So it's up 5, and there's the problem. If the whole thing is shifted up 5, you can now see that it's going to be starting up here and then going like this. They're never going to cross, and that's why there was no answer. So a graphical check, you could have just solved it that way pretty quick. Sketched the graph real quick and said there is no answer. They never cross. Moving on. Question 3. All right, so I would like to know when f of x is going to be equaling g of x. Okay, so set them equal to each other and let's get solving. So 2 square root of x plus 8 equals 3 square root of x minus 2. So it's kind of impossible here to get the radicals alone. This is kind of one of those special cases where we square both sides when it's not completely alone, but we'll talk about it in just a second. So let's square both sides, because that is how we are going to get rid of the radical. So if I were to take something like 2x and square it, since it's multiplication in between, I would take the 2 and square it, and the x and square it. And I'm going to do the exact same thing here. So when I have my square, I'm going to take the 2 and square it, and I'm going to take the square root of x plus 8 and square it. Same thing over here. I'm going to take the 3 and square it, and the square root of x minus 2 and square it, just like I did over in here, okay? Because I have multiplication. Technically, even though I didn't write it over here, there is a little dot right there. There is a little dot right there that's multiplication. Nobody really writes it because it's kind of a waste of time, right? So let's square it. So we end up with 2 squared times, well, the square root and the squared cancel. I'm going to put an x plus 8. On the right-hand side, we end up with 3 squared, and again, the square root and the squared cancel, so we're left with x minus 2. And I probably should have squared it out, so it's 4 times x plus 8 and 9 times x minus 2. Okay. So we got to solve it. It's still linear. We don't have an x squared, just x. So we're going to get 4x plus 32 equals 9x minus 18. And keep going. So get all the x's to one side, subtract 4x, we get 5x, and I just can't seem to write very well. Adding 18 over, we get 50. Dividing both sides by 5 will give us x equals 10. Kind of a weird one to check, that's for sure, but we can plug it in and do it up. So 2, I'm going to have to start writing over here because it will not be big enough. 2 square root of something plus 8 equals 3 square root of something minus 2. That something we just found was supposed to be 10, so we plug in the 10. Okay, so we get 2 square root of 18 equals 3 square root of 8. Does that look like it's equivalent? Well, maybe we should check the graphic check and see if we did something wrong there. Maybe we did, and we should just do the graphic check. So I'll throw the graphic check over here. Alright, so we have 2 square root of x plus 8. Well, I know that x plus 8 is inside parentheses, and it's going to move it left 8. So I'm going to have to pretend that this is left 8. Okay, and then it's 2 times, so it's going to be growing 2 times faster. That's my basic sketch there from my calculator for you. And then I have 3 square root of x minus 2. Well, x minus 2 shifts it to the right 2, but that's going to be growing 3 times, right? 3 times as tall or far from the x-axis. So that's going to be growing faster. That's why they're going to intersect. Okay, and they do intersect right about there. You go to your calculator, you can see that it's all the way over at 10, comma, it's like 8.4 something, 8.5. That is the world's worst 8. Fix that. So we really don't care about the y value. We care about, again, the x value. So it does intersect at 10, which is what our answer over here said, x equals 10. So why is our algebraic check not working? Well, it's because we didn't simplify the radical. That's why. So if we break the radical down, right, which doesn't sound like a whole heck of a lot of fun, does it? No, it doesn't. So we have to break it down, use our menu number factor. So this side over here is going to become 3 times the square root of 2 squared square root of 2, which gives us 3 times 2, which is 6 root 2. And this guy over here is going to give us 2 times the square root of 3 squared square root of 2, which is 2 times 3, 6 radical 2. Now, the algebraic check in this case was not fun. It was long, and it was quite a bit of a pain. And you don't have to do both checks, but you should do one. So if you realize the algebraic check is just going to be nasty, or you don't like breaking down radicals, go ahead and do the graphic check. If you didn't think that was so bad, which, to be honest, I really don't, do the algebraic check. It's up to you. And of course, you could just cheat this question by typing both of those in the calculator and seeing that, hey, they both have that decimal of 8.5. That means they're the same. That's always an option as well. Alright, looks like this is the last problem. So, we need to solve for x. So, 3 square root of x over 2 equals 15. People just seem to, like, I don't know, die a little bit inside when they see fractions. They cry a little bit. I don't know what's going on, but fractions really aren't that bad, so let's jump into it. The goal is still the same goal, and that's what you need to understand. It looks different, but you can't let that throw you off. The goal is to get the radical alone first. So I have 3 next to something, and I know in math, and you know in math, 3 next to something means multiplication. So I'm going to divide both sides by 3. So I now get the square root of x over 2 equals 5. And so the goal is still the same, get rid of the radical. So to get rid of the radical, I must square both sides. So x over 2 equals, we go 25. Now, 2 ways to solve it. I don't care which way you go about it. If you're a cross-multiply person, you totally can. Again, the reason we're allowed to cross-multiply, for those of you who've been having a hard time with that or doing it way too often, the equal sign. Fraction equals, well, we can make that a fraction. And because we have that equal sign, we are allowed to cross-multiply. So x equals 2 times 25, 50. Other way of doing it, multiply both sides by 2. So you have x over 2 equals 25. Multiplying both sides by 2, the 2's cancel, and you're left with x equals 50. I don't much care how you solve that one. It's up to you. Alright, so now we're going to do the check real super quick. That is not good. Yeah, we'll do the check. Call it good. Be done. So for the check, we have to plug in 50. Alright, so it's the 3 square root of 50 over 2 equaling 15. 50 over 2 is 25. 3 times the square root of 25. Yep, 3 times 5 is 15. That's a check. So 50 is the answer, should be in brackets. Good to go. The graphic check. Okay, well, 15 is the line that we're going to have. So here's y equals 15. And then we have to do the 3 square root x over 2. So that's going to start right here. It's going to grow pretty fast. Okay, I'm going to make it wider. The 1/2 x there that we have in front makes it a little bit wider, so it stretches it right out. It takes forever to get over here. All right, make it fit on here, and it doesn't hit until, you guessed it, 50 when you find the intersection point. Probably a lot faster to do this check algebraically than it is to do it graphically. There is no one right way, but as long as we do it one way, we're good to go. All right, so you got to finish your summary. Write your summary down there and do your practice. Thank you.